Now let's talk about interfaces. An interface in C# contains only the declarations of methods and properties, but not the implementations. It is left to the child classes inheriting from the interface to provide their own definitions. You can think of an interface as an abstract class that only has abstract methods and properties. Interfaces do not have constructors or fields on them. So they don't have a constructor, they don't have fields. Now the question that might arise naturally is this: why in the world would we have interfaces if we already have abstract classes, that we can make them act as an interface? This is an amazing question and one worth asking. Also, one quick convention: you inherit from classes, but you implement an interface. Once again, this is just a convention, but at the end of the day, it is just how you refer to an abstract class inheritance versus interface inheritance. But on the back end, inheritance gets performed the same exact way for an abstract class or an interface, which is via a colon symbol. So for both, you still perform inheritance just like this. So you just put a colon. The left side is the class inheriting from the class that you put on the right side, or an interface. But back to the question, why do we have interfaces? Basically, interfaces were made to get around the lack of multiple inheritances in C#. So that means that you cannot inherit from more than one class, but you can implement multiple interfaces. Let's go ahead and see an example. I will go ahead and copy the salesman class, the abstract class rather, and I will have another abstract class called salesman little.cs. I will add little next to the name, and I will actually take everything out. I will keep this a very simple abstract class. I will take this one as well, and I will just basically make this an abstract method, and that's it. Okay, very, very simple abstract class. Now I will go ahead and I'll say car salesman inherits from salesman base class, and it inherits from salesman little. See, I can't do it. Why? It says class car salesman cannot have multiple base classes, and that's because we cannot inherit from multiple classes. In this case, multiple abstract classes. In C#, that is prohibited. But the way to get around it is to use interfaces. So I'll take that out. I will remove this as well. So as you can see, that's the main reason. The other one is where to utilize each one. So abstract classes are meant to unify related class functionality into one unit so that it can be shared and maintained in one place, as we saw in the previous videos. Some of the functionality, as you know, can be predefined, and the rest of it can be abstract or virtual. It depends on the needs, requirements, etc. But that is the purpose of the abstract class. We already know this part, so this is just a refresher. Interfaces, on the other hand, are made to be completely abstract, and their purpose is to provide with an ability to unrelated group of classes. We can try our best to do the same thing we do for abstract classes via interfaces, but that would be putting a square peg in a round hole. Why torture ourselves and make our lives harder and other developers' lives harder when they are reading our code, if we can just use each tool for what it was made for? As a matter of fact, we learn through failure, correct? So let's go ahead and let's put a square peg in a round hole. Let's rewrite our abstract class and make it into an interface and see how it affects our code overall. This will show us even better why we didn't choose to use an interface in this particular scenario. Okay, so I will go ahead and turn our abstract class into an interface. The way you create an interface is via the interface reserved keyword. So I will say interface, and as you can see, I can't have fields, I can't have anything defined such as a method or property, and I can't have a constructor. So I'll actually take the constructor out, start from the retail person, bring it over here, and I don't really need this anymore except the name. So here we go, that part is complete. And then I will leave the method inside, that's cool. I will bring the properties, or rather, sorry, the fields into retail salesperson. Okay, that is all set now. And we can't have anything defined on our interface, so I'll take this definition out. We can only have declarations. We can have virtual, abstract, none of that. Just the signature of the method and our property defined in an abstract manner. So that means that we can just say that full name is a property and it has a get method, but we can't say what that get method does the way we have it right here. This has to be defined on the child class or the implementing class, which, you know, once again is just a convention. The way it's done is very similar. So if I go to retail salesperson right now, the method says that it has a problem because of the fact that we're using override. When we're dealing with interfaces, we don't really need to say override. We don't use the reserved keyword override with interfaces. That's only with abstract classes that have abstract methods. That's all. So we can take this out. As you can see, the full name doesn't exist. So what we need to do is we can just create that and then give it the definition right here. Okay. I'll just put it at the top just so it reads better. At least for me it does. But you can't leave it anywhere. It doesn't really matter. This is not a technical issue. It's just for organizational purposes is all. Okay, so now we have everything here. This works. Our salesman is an interface. And we can go ahead and grab all this stuff. Bring it to car salesman. And we will only need to change a few things here. We need to change the name of the constructor so that the constructor name matches the name of the class, which it does. And then here we just need to change it to car. And that's it. If we go to program, so as you can see, nothing has changed on the program class. We have changed the implementation behind how it works. However, the way classes get instantiated stayed exactly the same. So even with retail salesperson, I mean, it would be very similar to this, but if I was to say, let's just make another one. If I said retail salesperson and I said John, the sales dude, once again, switch up these guys here, say John Doe, then this basically is the same thing, right? The implementation behind it has changed. So before it was inheriting from an abstract class, but now it's implementing an interface. So the implementation behind it has changed. As you can see, we've done it. Right now, there's an interface instead of an abstract class, so as for the retail salesperson. However, the way we instantiate the class does not change. And I just wanted to show that to you. So once again, as you can see with an interface, we cannot unify all the functionality. So here, we still have our fields in two places, so we're repeating a lot of code. We have our property defined the same exact way. We have it right here. And we have our constructor that's very similar except the name, but if it was on the base class or the abstract class, then we would just have it once. The only thing that's different is the sell method, which before we had it defined on each class. So that's fine, but the rest of them is repetitive. So this is why we have used an abstract class for this kind of scenario. And what was the scenario once again? We basically had multiple concrete classes with shared functionality. So we unified it all into an abstract class and let only methods be overridden by each concrete class, since it was truly not shared. Now let's go ahead and undo all of the recent interface rewrites and turn salesman back into an abstract class, since we saw it was not a correct tool for our specific situation. So I will go ahead and turn this back into an abstract class. So that comes back, the method, the fields, the constructor, abstract class. Okay, so I think I have everything here. Car salesman will go back to its original definition. Retail salesperson will also go back to its original definition. So no fields, no property. Take that out. Okay. And there you go. So now it's overriding the method specifically. We have a constructor that passes in the fields to the base. Same here. And our salesman is an abstract class. So we have came back to our original state that we started from, But the reason why I wanted to do a quick rewrite is just to show you that it was not the correct tool for our situation, so that then we can see when is the right time to use an interface. I will now go ahead and create another abstract class called developer, followed by two concrete classes called web developer and software developer. These will have a very similar structure to the salesman with a few exceptions, but regardless, these will be an unrelated group from the salesman abstract class. New file, developer.cs is an abstract class, developer. I will only have one field. The field will be called main dev language. Okay, no property. It's a very simple one. And just gonna set that in the constructor. And here we go. All right, and then you have your developer as the constructor. And we will not have cell. Instead of, we will have something called code, and that will just say simply, so it'll say I am coding using my main dev language, and then the actual dev language. Okay, I'm coding using my main dev language, and that's it. It's a virtual method, and both of the other classes, the concrete classes inheriting from developer, will actually use the virtual. So those will be simple as well. So new file, web developer.cs. Copy the name, web developer, and then I will just basically paste that. It's gonna be very similar to this really, but I just don't want to write code, just making it simpler for myself by copying and pasting it in this case, so that the video doesn't get longer as well. Okay, so I will say that, and we can actually take all this out and let it generate automatically. I will inherit from developer instead of salesman, and the only thing we have is really the constructor. We will get the generic definition for code method, so that's fine. And then I will say new file, software developer.cs. So software developer, gonna be very simple to web developer, except the name. So we'll say rename, grab the name from that, and bam, we're good to go. Now that we have two unrelated groups of classes, let's introduce a new problem for which we will use interfaces as a solution to demonstrate how they work even clearly. The problem is that we want to be able to give certain classes, in this case individuals such as salesmen and developers, to have an ability to self-develop. Now you can argue that we don't need an interface for this. We can just go ahead and create separate methods, one for each class, that we want it to have a self-development ability. Let's actually go ahead and do that, and then we will see why it doesn't work very well. So I will go to retail salesperson, and I will say retail salesperson needs to have a method called develop. Okay, so this is develop, and it's going to say the following. For retail salesperson, it's going to say simply, I don't need that. So take it out. It's going to say I develop myself by watching retail sales training videos. Okay, so I develop myself by watching retail sales training videos. Cool. Now we'll have another method with the same signature on web developer. Okay, right here. I develop myself by watching Udemy web development courses. Okay, I develop myself by watching Udemy web development courses. Great. As you can see, we have the develop method as separate method in each class. In no way, shape, or form is it enforced by anything. For example, when we have an abstract method in an abstract class, and we inherit from the abstract class, it enforces us to override it and have our own definition. If we don't do it, the program won't run. This is a great reminder which introduces stability and regulation into our program. Since anybody making a child class and inheriting from the base class, which has an abstract method, would have to define that method. In our case, there are no rules to regulate as to which class has to have self-development ability. There are no regulations. Now you might be asking, why in the world do we need to regulate this, and how is an interface beneficial in this case, since it doesn't have any implementation, meaning that implementation is still going to be on the concrete class just the way we have it right here and right here. So with that said, how does an interface going to change anything? This is a great question. In order to answer this, we need to place ourselves into a more realistic scenario. Imagine you are working in a team of 10 people, and one of the developers decides to go ahead and rewrite your web developer class. So they go here and they decide to rewrite it. The person rewriting it then proceeds to take out the develop method and put it somewhere else. So they just take this out and put it somewhere else. If you don't have any rules in place that say a develop method is required in the web developer class, then the person rewriting will just not know anything about it. This will cause problems. If you had something that reminded the person rewriting it that it is required, then it would avoid a whole lot of trouble. For example, if you go to your salesman and make this an abstract method, right? Let's just keep this abstract for now instead of virtual. And you go to car salesman, and let's say I'm that same person rewriting this class. If I was to take the sell method and put it somewhere else, guess what? The program won't run because it says it is required. So then I would know, hey, this method is required. It's part of this class. It needs to be there and it needs to have its own definition. So something gave me a reminder. This introduced stability and regulation into the program. But with develop, here and here, we don't have that same stability. Anybody can come in and do whatever they want. They can change the name of develop. They can make it return a type. They can basically take it out and put it somewhere else. And there's no way for us to tell that other person that it is a required thing. Now, the other question you might have is, why don't we just put the develop method on the abstract class and let the abstract class require it from the inheriting class? Once again, good question. And the answer is because then all of the inheriting classes would need to implement the develop method, which in our case is not true. So for example, if you're saying that we should put the develop on the developer right here and make it into an abstract method, then web developer would require it, of course. But so is the software developer. But our requirement is that only the web developer has the ability to self-develop. So that would not really satisfy our quote-unquote business requirement. Now in the next video, for a continuation of this one, we will actually put an interface into place and see how it solves our current problem.